Good morning and welcome to Data Center. In the last class, we considered how to join, merge, replacement, and we looked at the different kinds of join: the left join, the right join, the inner join, and the outer join. We're taking it a step forward today by way of uh, importing a Titanic data. I've downloaded it already. You can search for it on GitHub. Once you open your browser, just search for the Titanic data set. Can get it on GitHub, can get it on Cargo as well. Okay, so I'll be working on their data set and then we'll perform certain inferential statistics. Right, so you open your PowerShell. This is my PowerShell is open already, and then you make sure that you change your directory to, if your folder is on the desktop, that change the directory using CD. Mine is on desktop, I have to change it to this folder, and then I open my Jupyter notebook. Okay, right, so we once you do that, it will open a kernel for us. This is it. So let's open this now. Python 3 is opening. Okay, that's open. So I want to do this. Let's click on this code, click on heading, then click on OK. And basically today we'll be looking at inferential statistics. That's what we'll be looking at today. Okay, so let's import pandas as PD, import numpy as np. I love importing all my libraries, at least basically cborn as sns, even import maths plots live dot py plots as plt. All right, let's read through our file now. df is equals to pd dot read is a csv file, and we open. The name of the file is titanic.csv. That is the name of the file. I guess we can open it now. .ed. Let's open and see. Okay, this is it. Look at this. You see we have some missing, not available. NaN means not available. This means not available. All right, so let's check for the missing value. So I'm going to do this here. I've done that in the previous one, so I'll be a little bit fast with it. Data cleaning or wrangling. Okay, now we want to look at df is null. Okay, it's a method, right? Let's add it. Let it sum it for us and tell us those one that are that's empty. We want to see those ones that are empty. Okay, you can see from here we have this. At age, we have missing rows. At cabin, we have missing rows. Okay, so let's quickly perform. Let's remove it. For now, I'm going to remove it. You can replace it. If you look at the previous class, we did how we showed you how to replace missing row. Okay, maybe with a particular value. Okay, df dot drop na. Okay, in place equals to true. Okay, so we are dropping the missing row from this place. Let's run it. Now let's check. Let's check to see if we still have a missing row again. It's not. It's dot not comma dot sum. Okay, let's run this. All right, let's check. There's no any missing row again, so we've taken care of that. And the next thing I want to do is this sex. If you scroll up, let's look at it. Look at it. We have male, female. So you see, I want to change this to numeric. Okay, numeric. Let me change this. Come to your code, change it to heading. Click on OK. Then replacements. Replacement of female and male category under sex with numbers. Okay. Okay, so now we want to replace that with number. Okay, so we'll be using one of these machine learning techniques using the scale uh, learning from sklearn dot pre-processing. Okay, import label encoder. Okay, and let's declare instantiation of the label encoder, please. Label encoder is equals to encoder. Okay, okay, so we have this. Let's bring in this now. We have 6 is equals to label. I'm making reference to this now. Encoder that fits 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 underscore transform. Okay, df okay. So let's check and see df dot add. Let's run this. All right, bravo. If you look at it now, you see under sex we have 00100. Okay, so it has replaced this for us. Okay, so now we can go ahead with our analysis. Okay, let me change this now to chi-square. That is the first analysis I'll be doing. We want to run chi-square. Chi-square. Okay, chi-square is used for contingency table. If you have been following the class when we considered the MySQL, sorry, SPSS, we did that and we said MySQL is sorry, chi-square rather is used for to test for association between two groups. Okay, and then we have Fisher exact test too when the sample is known. Okay, you between up to 1000 sample use Fisher exact, but if it's more than we use chi-square. Okay, so we'll be looking at that briefly next year. Okay, so for we to be able to perform chi-square, we have to import another library from scipy. Okay, so we have this from scipy.stat. From scipy.stat, we import chi-square contingency. Okay, so that's what we will be using this library for this. And okay, now Let's move forward. We have count C. Okay, there is I want to just leave this. Now we want to compare two group. Okay, let's assume we have under sex here. Yeah, okay, and we want to compare it with those that survive. Okay, so these are the two tables, to the survived groups and the gender group. Okay, is equals, so let's use this pd dot cross tab. Okay, we open this df and then we specify survived. Oh my, survived. Okay, yeah, sex. Okay, so we've selected the two group. Okay, so the next thing is, what do we want to perform? Okay, so now this is where we now specify the equation. We need chi-square, we need the p-value, we need degree of freedom, that's 0f, and then expected is equals to chi-square contingency. Then we put these counts inside count. Okay, okay, okay. So let's then print our result out. So we're going to use the print method f because we want it to produce this chi-square value, chi-square as stated here, the p value. Then I want to add another thing to it too, and that is DOF, DOF, curly brackets, DOF. Okay, can we run the printing now? Okay, let's run and see. Bravo, you see our result. The chi-square value is this, the p-value is this, the DOF is 1. That's the degree of freedom. Okay, so if we look at it, the p-value, if we were to interpret, is more than 0.05, so it's not significant. Then the coefficient, the chi-square value, if you look at it, is association. There's an association, positive association between the those who survived and the gender. The degree of freedom is 1. Okay, you can see our result here. See our result here. All right, the next thing we're going to do is to, let me change this. I want to run one way ANOVA. ANOVA means analysis of variance. Okay, now we are also using scipy.stat because we are still running this. Okay, so we're going to import, sorry, cancel this here, yeah, from scipy.stat import f1 way, right? Okay, for this we needed is df dot using the group by method. If you remember, we considered that in the last class, one of the class we had the group by. Okay, so I have this to go. The column. Now, if you remember very well, when you are running for when you're running for your one-way ANOVA, we said that your independent variable must be categorical, that is your control. This is where it comes. Then the value here, that is your that is dependent, it must be continuous. Okay, so let's look at our table again. What is continuous here? If you have to look at it, that is a fare. The fare is continuous. The money paid is continuous. This okay. So can look if there is significance between is a relationship between the P class and the fare paid. Okay. P class and the fare paid. Fare. Then we're using the apply list. Okay. Let's check P class. Then fare. Okay. Fare is continuous. It's not categorical, it's continuous. While the P class is categorical according to the class. Have class 1, class 2, and class 3. The next thing to do is to bring in the equation to calculate a one-way ANOVA, which is F statistics, the P value, and then this is GRP. Okay, that is this. We are saying the F1 multiplied by the group. I would love to add DOF2. Let's see. Okay, is F statistics, the DOF, then the should we add t value or t statistics? Let's just leave this p value and then f1 way. So let's see how to print a result out now. I'll just copy this. Let's type. Let's see. Print f. We have f statistics. F statistics. F statistics. UF UF P value P value. Okay, okay, so we want the SRTC DOF and P value. Okay, let's run. Okay, we have an issue. Let's look for where the issue is coming from. Print line 4. This is the place where the issue is coming from. I will trace where the issue is coming from. Okay, we miss a quote. Let's see if we can close the quote. Miss a quote. Okay. Where is it? Okay. Let's run this and see. Still not enough. Let's look at it again. Okay, since we're having issues, let's remove DOF. That is degree of freedom from this. Okay. Then this is there. Okay. So with this, we can go ahead. Okay, say value. Okay, this is it. All right. So our F statistics value is this. Our P value is this. Okay. So F statistics is about the significant size is about 10 minus 15, right? Okay. So we have the F statistics, and then we have the P value. All right. Right. Here we'll go to two-way ANOVA. Okay. So the same. I will import scipy.stat import factor uh, factor factor analysis. Okay, before we proceed, I will also love to show us another approach using the model fit. Okay, using the model fit. Let's move this up. Let's see. Okay, using the model fit like this. So we'll come back to our two-way ANOVA. So I'll be using the type 1. Okay, the type 1. Let's use this. So we have the import stat model. That is the model we'll be using .api as SM. From the start model, the formula API, I want to use this ordinary least square. Ordinary least square OLS. That's what we'll be using. So we attach our model is equal to OLS. This sphere I'm using here is a dependent variable. That is our target. And then the sex is an independent variable. Okay, and the data wise is DF. Then we are fitting it into this model. Now I'm going to put type 1 here. Okay, so let's run. Okay, so you can see we have the DF, we have the sum square, we have the means SQ, we have the F value, and then we have the P are greater than F. Okay, so is it greater than F? Nope, it's not. Therefore, the residual is none. Okay, so let's now move straight away to our ANOVA. Now, for ANOVA, we will not be able to use this for now. This scipy stat, we will use this same approach, the start model. I'll copy this. Okay, but this time around, I'm going to add something to it because for your two-way ANOVA, you have more than two independent variable or more on your dependent variable. Okay, so as over here we have age plus okay, we have here we have age. I change this to type 2. Okay, that is to type 2.